Welcome to the channel Tribe. In this session of TTTribeCast webinar, we are having Cristiano Cunha discussing on the new performance game.
Okay, so I'm here to talk to you about a theme that is close to my heart, that is performance and performance testing in a more specific way. And I call this talk the new performance game. Before entering into this, I wanted to present myself, but I'm not going to take much time here because I already was introduced and it kind of covered everything. I just want to give you a brief context about my evolution. As you saw, I started as a developer, evolved to be a tester, and when I was there, I started to see that a lot of things needed to be done in order to increase the quality. One of those things were performance, and at that time, as we will see, performance was not something that was cared about within the team since the beginning of the conception of their requirements. So that's why I started looking at that. Then I shifted to infrastructure. So I was also part of an infrastructure team that wanted to invest in automation, and we kind of converted the automation team that I was leading into an infrastructure team to focus on automation. That's why I get in touch in pipelines and all of these changes that needed to be done in order to adhere to this new way of doing things. And now, back in X-Ray, I'm back to the testing area. I'm here more contributing to the community, interacting with everyone, trying to learn things from the community, and also giving support to the product I love, that is X-Ray, and everything technical about it. So technical partnerships and all of those things, some demonstrations that I do also in the community. If you want to know more about me, you have the links there, Twitter, LinkedIn, and my blog. So feel free to join, to add me. We sure will have some healthy conversation. But let's jump into the subject. What exactly is performance testing? So performance testing, by definition, is the practice of evaluating how a system performs in terms of responsiveness and stability under a particular workload. Performance tests are typically executed to examine the speed, robustness, reliability, and the application size. So we can look at the system to understand how it behaves in terms of speed, so to understand if the application responds quickly enough, or also in terms of scalability, to understand if the maximum load of the software, what is the maximum load of the software, or look into its stability. So to understand if the application is stable enough when we are varying the loads that we are hitting it with. To address those needs, there are different types of performance testing. And in here, like any other area in testing, actually, the naming is not always the same. But I'm just going to talk about some types of testing. So performance testing, we have like load testing, stress testing, endurance testing, spike testing, volume testing, scalability testing. So all of this have different names. They will be described in different ways, but and will target different objectives for you to evaluate the performance of your application. So you need to choose wisely what you want to validate. But what I want to say with this is the naming is not important. The objective is important. So even if you are not calling it the right thing, define something that you want to try to validate in terms of performance of your application and design the right tests to it. So this is the first thing. Don't go and say, well, I'm going to define the load tests for my application if you don't even know what load testing is. Start the other way around. Start by asking yourself, what is the performance issues that I want to, or challenges that I have that I want to solve or that I want to validate? Because that will help you then shaping the performance tests that you need to do. But now that we kind of have an overview, really quick overview about what is performance testing, let's look how I have seen it evolving throughout the years. So when I started in performance a while ago, I'm not going to tell how much because we will find how old I am here. Performance testing was way different than what we have today. So back in the days, performance was handled pretty much like a waterfall process. It will start at the end of, so exactly before delivering your product, your service to production. So everything was done, the build was done, the functional testing was done, and then they kind of delivered this package that is the release and now validate the performance of it. And then if everything goes as expected, we can put it into production. So these heavy performance tests were managed by usually highly skilled professionals. Usually, they are a separated team of performance gurus that will come in and just let us know if the performance is okay or not, whatever that means at that time. So to achieve this, we need these highly skilled professionals that actually were not part of the development team. They are just coming in to validate the performance of other applications that we may have. They are usually a central team that will do performance validation for different teams. And this, as you may start thinking, is causing a problem. That is, when you have a team that is not used to your application, that does not knows the workflows of it, that does not know how it is deployed, what are the requirements in terms of software, of hardware that they need to run, they will need to interact with the development team, with the operations team, in order to gather that information. So it will bring here a heavy dependency towards that team. Another thing that was tricky when we did this in the past is once you have a team that is labeled as performance gurus or performance professionals, they are kind of responsible for the performance of your company instead of spreading the word on the development team about what you need to care about in your projects related to performance. So instead of the development team start to learn on how to ingest that performance in everything they do, they kind of don't care about it because at the end, some professional will get there and validate their performance, and then they start interacting with each other. Of course, also, when something happened so late in the game, so before production, and these guys find some issue in performance, they will come back to the development team to try to understand what's wrong, because they have not built the application. So they need to interact with operations, with development team to try to understand why is this slower, why is this causing an issue. So this is just one of the things that bothered me when we started doing performance. The other thing is to have this, to execute these performance tests, you also need environments. And those environments, usually what we get is when you ask, so what kind of environment do you need to execute those performance tests? And what we get from the development team or the performance team, yeah, of course, we need a production-like environment. How else can we extract conclusions regarding performance if we don't have a production-like environment? And that's the beginning of the problem. Because once we have a team that will need all of the shebang of services, of data, of dependencies that we have in production to validate performance, it will be an issue. An issue, why? Because when you are starting to build that environment, you have several issues that were not addressed. For once, the operations team or infrastructure team at this time is not heavily investing in automation. So the provisioning of virtual machines is actually manual. So it's hard to do. I remember in my time, what I did is I created a ticket for infrastructure team requesting a virtual machine with this and this and this parameter, and then just wait for them to reply me back on when is the virtual machine ready. And that's, as you may think, infrastructure is not a team that is really, really fast on responding. I was there, so I know, not because they don't want to, but because they have a lot of other things to do, including support to our end users. So it takes time to get answer back. And then when I saw how it was done, it was, well, the guys that have some automation are using actually scripts that they have either in their machine or in another machine with that naming that was like, I don't know, put machine up underscore Cristiano underscore backup 2 underscore backup trick 3. And we didn't know what was the script that we needed to execute, because we didn't know which one of those have the best tricks to put things to work, because it was all in the head of the guy that have built that script. And of course, that also caused problems of stability. It was not straightforward to execute the script and have an output that is a virtual machine. Probably they have a hybrid virtual machine that comes out of the process, and then they go there manually and shape things up in order to make things working. So this is one of the problems of needing a production-like environment for you to execute your performance test at the end of the process. The other thing is the deployment. As you know, the deployment, usually when you are in Agile, not yet in DevOps, you are relying on the infrastructure team to do the deployment in production and to maintain it also. But the deployment is not something that was automated most of the time. It may have some scripts to automate some bits of it, but you need someone manually doing the deployment. So it was hard to deploy your application in your virtual machines or in your machines. And bear with me, there was not Kubernetes at this time when I was in this endeavor of understanding how we can set these performance tests. So I'm talking about virtual machines. But coming back to the deployment, we have several issues. Not automated, so most of the time we need to execute it 2 or 3 times to make sure that the deployment was exactly working. No validation of the deployment, so once the deployment task was done, there was no assurance that the deployment was successful or not. We need to go there and check if the application was running. Sometimes the deployment was not understood by the development team. That means that all of the parameters or arguments that you need to pass on to shape the configuration towards a specific environment was not passed correctly once you are triggering the deployment. So you end up having environments with applications and services installed with wrong configurations. And this is really hard to understand when you have a web of services, of microservices that depend on each other. And one of them is kind of running successfully because it doesn't provide any errors, but then the others that are calling it are providing errors, and we really don't know why. And sometimes it's just a username and password that is not the correct one for that environment, an endpoint that is not the right one. And when you are deploying your application, the other one, the other struggle that I had is dependencies, because your application does not live alone, at least not in my experience. You always need other services that you rely on. And all that I talked about regarding the deployment is also true for the other dependencies, because if you install your service, you need to install every service that you depend on, and so far and so forth, because all of the services, all of the dependencies that you're going to install will have dependencies also. So you need to install virtually everything that you have in production in order to test your application. And this is also tricky because it's hard to, if you have brittle deployment and you want to deploy hundreds of services, it will give you hundreds of headaches for sure. The other thing that is hard to do is data. when you want to build an environment, actually what you end up doing is asking the development team or the performance team, what kind of data do you need for your tests? And the answer, in my experience, is everything. And everything is not a good answer to have because if you have terabytes of data in production and you want to extract that back into your performance environment in order for you to do the closest test to production that you can, it's hard. So you need to at least talk to the development team and try to understand what are the data that they need, the most basic data that they need for the service to start up. And sometimes this is a real discussion because in my experience, when you build your services, and because you're not used to repeat the deployment in several environments from scratch, you don't really know, or I came to realize that they don't really know what is the basic data that they need to have this service working. That means that they assume that there is some data already there that their service will work with. Instead of, in the deployment phase, deploy and provision all the data that their application will need. And this is struggling. And also, all of the systems that we are building, in my experience, is we are not following all of the best practices regarding data. Because we try to make things work as we are going, not following or not normalizing the data, or not using the best approach regarding the strategy or the scheme of the database, or sharing databases or tables when we shouldn't, because it's easier. And then all of that build up on the data will increase the complexity of having a subset of data, because it's not just fetch me the 5 or the 10 products that you may have, because I only need those, but because we will need the stocks related to that. You need the orders that they are part of. You will need all of the sizes that are being used by that piece. So it's not only extract those products, it's those products and all of the dependencies that you have on the database in order for them to work in your environment. So building an environment was something really hard to do. So first, the provision of the machines, just the virtual machines, will take a long time. And then all of these things, to have all of the services installed with all of the data, waiting for me with the right versions, because don't get me speaking about maintaining this, because it's a nightmare, and I've been there. And everything that you have here will take a long time. So probably months until you have an environment that is ready to receive your performance tests. And of course, imagine that you are in that time that, well, finally, I have my environment, let's start my performance testing. What usually happens is I'm getting at the end of what is my delivery regarding the performance test, and of course, the environment is down all week because someone has messed up a configuration and one of the service is not working, and because of the dependencies will impact my performance test, and I cannot redraw conclusions regarding performance of my application. So this is another headache that is really, really hard to come by regarding performance tests. But hey, we did it. We did some tests at the time. And when we manage at that time to execute those tests, so you have the performance tests defined, you understood the workflow, we interact with the development team, you are ready, you have the environment. So you push your tests, I get that environment, and you start getting data. And usually, the other thing that you need to consider is results and data. Because in performance tests, we will have test results of what was done and results of each action and all the data that is extracted from the virtual machine. For example, such as memory, CPU, network, time, number of users, number of requests, and so far and so forth. Because we need all of the data to be saved or recorded in a way that we can reach to meaningful conclusions, because we need to be able to correlate the data of the tests of my applications, of the environment, because at the end of the day, everything is connected in a way that we need that information to reach meaningful conclusions. So, first of all, once you execute everything, usually the tools will record all of this data and put it somewhere. And when something happens, you need those performance specialists to go there and try to make sense of all that data. You want them to go there, and if my services request time is smaller, higher and higher, what is causing that? So they need to cross all of the data. They will need to know if the database is healthy, if the requests are healthy, how many users are using that, is the network okay? Do we have any service that is not okay? What is causing this increase of time of my service? And with the amount of data that we have available, it's hard to read and it's hard to reach conclusions. So more than just recording, having that, you need those professionals to make sense of all that data. And you need also to be able to redraw conclusions. So even if you don't have any issue performance-wise after interpreted data, you need to have a manual validation if the performance test was okay or not. So those performance professionals just go there, look at the data, look at the tests, validate everything is okay, and they will say, well, performance-wise, we are okay. But we need them to do that. We don't have ways for this to happen automatically. And as you know, these tests usually that comes at the end of the process are heavy. So you need this environment, dedicated environment where you have everything there. You need resources on the side to run the performance tests. So you have more than the performance environment. We have also machines that will execute the testing code that are separated, because we don't want to impact what is being done with the tests regarding performance of my application. And you have all of these results that are shipped in that need to be interpreted by someone that understands what it says. So it was a really pain to do performance at that time. And just for information, performance for our end users is more or less translated into what I call well, the industry calls the SLAs, SLOs, that are service level indicators, service level objectives, service level agreements, that are actually three initialisms that represents the promises we make to our users. So the agreement is the promises we make to our users about the capacity of our application or service. We have also the internal objectives that help us keep those promises that we define, and we have also the trackable measurements that tells us how we are doing, that are the indicators. So the indicators are what we are gathering that will allow us to define objectives, that will allow us to define an agreement about how well will my application will behave. And sometimes when I say here our users, when you are in an infrastructure team, your users are the development team. So we also come up with this in order to make this agreement with our development team when I was in an infrastructure team, to understand how is the infrastructure that we are providing for them. So these are indicators that are important, because they will allow us to have those gates, those automated checks against the agreement, to understand if we can or not pass this this issue or challenge. So This is one of the appointments, not that's related to performance per se, but it's a way to introduce also the concern that we need to have something that we can validate in an automated way in order to insert this performance thing into closer to what we need to do in the future. So far, it's really hard to think of how can we put all of this process, heavy process with external teams involved, closer to the code conception, because it's now at the end of the process. And being at the end of the process also makes it hard when you find any issue, because probably the team is already working on the next sprint and the performance team is still saying, well, it's not performant enough, we need to redefine things here. And when we reach that stage, we have like all of the features that were released in that sprint. So instead of focusing in one change, you are focusing in all of the changes. So it's hard to come with understanding of what is causing the issue. It's another problem of being at the end. So for our objective, we need to be able to fail a test when a predefined threshold or gate as breach automatically. And we saw that even when Agile came along, the only enhancement I saw regarding performance testing was to parallelize performance testing with functional testing, just in an attempt to shorten the time that it takes. But the true change came along with DevOps practices. And before getting into DevOps, let me just say that if you see anyone that say, of course we are DevOps, we have a DevOps team, please don't. They are not DevOps. They are no DevOps team. That's not the way that we want this change to happen. DevOps is a cultural change, is a mindset change, is a process change. It will change the way that you will deliver your code into production and how you maintain it there. It's not just creating a DevOps team. So help me in destroying these concepts of a DevOps team. Now that I get that out of my system, what is DevOps and how it changes the way we are doing things, and by consequence, the way that we are doing performance. So now DevOps, that is characterized by this infinite loop, will bring a word that is really, for me, the best thing that will describe DevOps, that is continuous. You will see that we will have new concepts appearing, that is continuous integration, continuous delivery, continuous deployment, that will come to shape the way that we are doing things. I will add two more, that is continuous learning and continuous testing, into this continuous way of doing things, because now, and the biggest change about DevOps, or Dev QA Ops, because we don't want to let the tests out, is actually bringing everything regarding infrastructure and operations within the team. And when I say that, is not just take out the infrastructure guy and put it within a team. It's enabling the team to be autonomous regarding everything that they do with their product, meaning that they will need to be able to put their application into production autonomously. They will not need to rely on an infrastructure team or an operations team. They need to have that ability themselves. So you can continue to have an infrastructure team, but they will need to provide you with services that will enable autonomous teams within your company. And now we have all of these new concepts. So continuous integration, delivery, and deployment are all practices that will need continuous automation, because you will need to continuously automate the way that you are doing things. This also brings a new concept within this new mentality, this process change, that is pipelines. So in order for you to have continuously integrating your work or delivering or deploying it to production, you will need to have ways to do all of the validations that you need, all of the work that was done either manually or by scripts into one big pipeline. And what is a pipeline? Pipeline is something that, like we are seeing here, that is the visual definition of what are the stages that we are going to take until we get our code until production and how to maintain it. It's basically the sum up of everything we did manually more in an automated way. So we need to extract the code, we need to build the code, we need to run tests, we need to package the code, we need to deploy the code, and we need then to monitor the code. So all of these different stages will need also different tools. And all of these tools kind of exploded with DevOps because we will need tools for basically everything. We'll need tools to build, we'll need tools to package, we'll need tools to run tests, we'll need tools to deploy. And that kind of exploded, and even that we got this periodic table of DevOps tool where you can see all of these different areas that we have with the tools that are it's obviously outdated, because the moment it's out, it's outdated because new things will appear. But it's just to show you that there are a lot of tools that you need to consider, and there are a lot of new ways of addressing this new way of delivering software to production. And of course, what changed also is the functional and non-functional testing. Because in the past, when it is okay to execute things in a more manual way and draw conclusions, waiting for the tester to draw those conclusions, or the performance tester to draw the conclusion, was okay. But one of the characteristics of the pipeline is it needs to be fast and it needs to be reliable. So all of the tests, either functional or non-functional, needed to have a way to understand if they have passed or not for the pipeline to progress and deliver your process to production. And having 3 hours in one execution of the pipeline is not okay, because we want to enable the teams to do this as fast as possible. That also means that all of the processes, all of this sum up of stages must be as minimum as possible. And this will depend, of course, on your team. So what is the minimal acceptable execution that you may have in your pipeline? So it's for you to say, and then you need to be strict about it. So if you see one of the stages that is taking too much and is taking the most time of the pipeline, you need to address that. You need to understand what's going on. And this redefinition of tests will make you shift left. So you want to address or validate things closer to code conception, because it will enable you to react faster and to define ways to understand what's happening way better when you know exactly what is the code change. And also shift right, because now you need to care about what happens in production. You need to be able to monitor what's happening there, to observe everything that is going there. How is the deployment going? How many rollbacks did we had? Why? How is the performance in production? So all of this new responsibility is now also within the team. So they need to develop also new ways of understanding this. They will need tools, they will need support about how doing so. But all of these tools, and one of them, the non-functional ones, are defined by security and performance. So now we have a greater concern within the teams, because now they are responsible for the performance of the application. They are responsible for any security issue that may happen in production, because they are the owner of the application since conception until production, and maintaining it in production is not just deploying. So it has opened up the scope of the team, and they need new ways to address those things because the old ways are not working anymore. And the tools have also reacted because we see new tooling appearing that will enable you to shape performance to this new way of doing things. And here I just have a subset of some of them. Well, it's my choice of subsets. So we have Locust, K6, Gatling, and JMeter. That for me are the tools that will enable you to shift left your performance. And to do so, you will need to think of performance, not that big chunk of tests in a production-like environment where I want to validate the overall performance at the end of the sprint, but cut that down into pieces. Try to define your tests targeting a specific area or a specific part of your application. And these new tools will allow you to do so with code and to do so recurrently. So the first difference that we have is they will be shortened, so some minutes to execute. They will target not the entire application, but a subset of it. They will also define a baseline that is really important. So the first execution that we will do of this new performance tests will be to define what is the baseline for that feature, that release that you are going to do. That will define what you expect to be the performance of your application. And then any subsequent executions, so any new builds that will come by, will execute the same tests in the same conditions, extracting the same data, and we will be able to compare, to have an historical trend of how is performance going for your application. And this is what will allow you to react, to understand in comparison if my application in each commit, because remember, now we have pipelines, so we are continuously integrating code, and in each commit, we will execute this performance test, we will extract this data, and we will compare it against the baseline. And once we do this, we will know feature by feature if they are hindering the performance or not of our application. And that will allow us to react really, really fast and to draw conclusions even faster, because we will know what is the feature that is impacting the performance. But of course, when we start talking about tools, it's really overwhelming because there are all types of tools everywhere. And one of the downsides of the DevOps is we don't have, well, it may be good, maybe bad, depending on the interpretation, but we don't have one tool to serve all of the purposes. So we need one tool that will handle the other tools that are usually the orchestrators, and they will try to put all of the tools together. So I just want to leave this message here that is, don't rush into tools just because they are cool. Think about your process and how will that tool be beneficial in solving your technical challenge, but also how can you or how will it contribute to the process and to the overview of the visibility that you have of that tool. Because if you are just putting a new tool there that will, of course, do, I don't know, a performance validation, but you don't have it integrated in your pipeline, no one knows how to reach those results, and you need to manually interpret that and incorporate it in your pipeline, it will not serve your purpose. It will instead delay what you are trying to do. So think of tools in ways that they will solve your technical challenge, but also how can you bring that visibility back into what you are doing. Because I did a talk a while ago about inconspicuousness. and the inconspicuousness that you can find in our systems, and actually how to fight it. And inconspicuousness, because it's the question I have when I did that talk, is what the hell that means? And it's actually an adjective that means that something is not visible or it's not attracting attention. So it's there. It's not the same as being invisible. It's actually there, but because it's not attracting attention, no one cares about it. So all of the inconspicuousness that you may find in your processes, in your company, in your tools, will hinder your speed and your quality, because you need to be able to integrate everything, to have visibility of everything, and to share that with everyone. So visibility, when you are choosing tools, are really key here. Choose them because they will solve your technical challenge for sure, but also choose the ones that will integrate better in your process to bring visibility, to add up on the visibility that you are doing, because you will see that will foster collaboration. Because once everyone knows what's happening and everyone is responsible by the product that you are delivering, they will need to chip in and help for sure. But if no one knows what's happening and no one knows how to get that information, they will for sure not know how to help, or not know how to collaborate, or not know how to get you out of that process. So be aware when you jump into DevOps that the choosing of the tooling is really important, but try to define a process that suits your needs, and then think about what are the tools that will help you solve those problems. So for me, and I'm here talking more about performance, I have chosen Gatling. Why? Because I can, and because one important thing is I don't need to worry on the context or team, and I wanted to learn Scala. Why do I say this? Because sometimes when you choose a tool that has a language behind it, like Scala, it's really important for you to choose something that your team is used to, because at the end of the day, it will be one time that you will need help. And if you are choosing a tool that your developers and the other elements in your team are not used to work with, they will not help you, and they will not feel at ease to help you develop it. So one of the important aspects also by choosing languages and tools is choose the tools that have the same languages of what you are used to use in your team, because they will surely help on whenever they need, and even help you getting things better. But what is Gatling? Gatling is actually, as they say, load test as code. So it's actually the best way to load test your application. It's actually designed for DevOps and CI/CD. And this is actually the actual definition that they have there. So discover the Gatling load testing tool. One of the things is actually that design it for DevOps and CI/CD tool, because they have an integration with Jenkins, for example, where they exactly do what I just said, that is defining a baseline and then having a historical trend of the performance of your application. But more than that, it's code-like scripting. So we will see that Scala is really intuitive in terms of writing the code. I'm going to show you in a bit how we can do it and how we can define a performance test in order for us to be able to assess the performance of our application. It has a domain-specific language, or DSL also, that we'll go over. It is available in Scala, the one that I chose, because I never use it. I'm really curious about it, but also in Java and Kotlin. So you have the choose of the language. It actually generates out of the box a report, really colorful one. It may be overwhelming at first because it will have all of the data that is gathered by the test at that time. And it also able to integrate in your pipeline. So this is a view of things that they may add to your pipeline once you are doing things with what I just talked about. So again, making sure that when you are adding a tool, that you use a tool that is the better for your team, for your challenges, and for the purpose that you want to address to. My case, I chose Gatling, but any of those tools are really awesome. So Locust and K6. See the one that feels better on using. Do some proof of concepts internally to see what better suits you. For me, what did it was the Scala thing. I just was curious about it, and I wanted to try it out. But nevertheless, it was a good surprise because it handles really well. So next, what I want to do is a small demonstration. So small bits of code that I'm going to go over with you, execute, and see how we can extract all of that. So let me shift real quick. Oh, sorry, not this. Shift real quick to what I want to show. So for this example, I'm going to use this Blaze demo site that they have that will allow me to assess performance. Blaze Meter actually has this site available for you to exercise your performance test, so to try it out, the Blaze demo. So I'm going to hack this or use this instead of having a site made for myself. It's really a simple site. You just have to choose departure city, destination city, find flights, and you to actually list the flights, and you can choose one of those. And that's it. You don't know. You don't have to do anything else. So it's really simple, and you can purchase it. So I'm going to use this. I'm going to define tests using Gatling. So I'm jumping out of myself. And in here, let me see if you guys can see. Do you need it bigger, or is it enough for you guys to? Probably small. Let me put this.
Hi, Cristiano. A little bigger would be helpful because this is a little small for people to.
Okay. Let me just blah, blah, blah.
Folks, also on the AirMeet, there is a full screen button at top right. So you can also full screen, while the time Cristiano can also increase the font size. So we can do both ways so that you see a larger picture.
Yeah. Let me just figure out how to do that. Well, I'm kind of no. Kind of Do you know where it is? I kind of lost it for now.
Somebody's saying control plus scroll up. Control plus scroll
Let
up.
me see. No, this is the Mac, so probably control plus. No, command plus. Here it is.
Yeah, command plus. I think it's
better.
Yeah, command plus.
Yeah.
This is better.
Command plus. Good tip, nevertheless.
Good hack.
Thank you, guys. Good to know that you guys are there. So coming back to this, this is actually an example that I did for X-Ray, but it will serve our purposes. What I have here is just a definition of a test. I actually have two tests defined that I'm going to go over with you. That is one that's going to try to assess the performance of that Blaze Meter site. And let me just, let me execute this the first time and we'll see what happens. So going a little bit over what it's being written here, it's the simpler or most readable test that I can occur. Basically, you need to include, I'm using Maven to execute those tests and define the Gatling one exactly here. So I include IO Gatling. my class needs to extend simulation in order for them to understand that I'm defining a new simulation for my tests. In here, I have defined 3 different operations that are described by how I want to interact with the site. So the first one, it's an access login that will actually use this endpoint and will pass this from port Paris to port Buenos Aires. It's not actually a login because I was thinking about making a login last night, but then I saw that there are no login there. So I just leave it here. It's the same as the reserve one, but it will show you that you have different indicators that are saved per process that you are defining here. The reserve one, it's exactly the same. I'm adding a pause at the end. It's just a way to try to simulate human behavior, because that's one of the issues that we may have in defining performance tests, that they are faster than a human to execute, and then it will not exactly emulate how users are using your site. So I'm adding this pause here just to try to emulate that bit of a pause when you are confirming the data before clicking the next button. And then the purchase option is a little bit different. So exercising another endpoint and passing different parameters, and also pausing this at the end. So in here, I can define as many as processes do I need in this simulation. And I will use the HTTP protocol. So I'm just defining the HTTP protocol with the base URL that I'm going to use. Of course, this can be put it in a configuration file or anywhere else. So, but for this example is simpler. And you will see that this base URL will be added upon with what is passed on the post. So the endpoint, the final endpoint for each one of these processes will be this base URL plus this endpoint. Then I define the headers, if I want to track those headers or not, and then just adding some things to the header, a user agent. Sometimes it's helpful to define a user agent, and this ability is really important because sometimes when we are executing those performance tests and we kind of get wrong the base URL that you are using and accidentally you're using production, it's important for you to distinguish your performance tests from an attack or from a bot or from something else. So the ability to define a user agent is the easiest way to put some kind of identifier to let the rest of the team know that, well, it's you that is actually doing some load on production. Better way, it's not doing the load in production, but adding a user agent is also good because if something starts to happen, they will see and they will connect it back to you really quickly. Then I'm defining different experiences. So I will define a login user that is actually use the scenario, the process that I have defined called login users. That is the name that I'm going to give, and it will execute the login process. That is exactly what is defined here. I will have also reserve users and purchase users. This will help me define the scenarios I want. And in here, it's 3 different processes to do different operations. And we can have like admin users, normal users, and other users. And we can shift the permissions that we may want to have while running the test. So it's a good way to do so. In here also, you can concatenate the experiences that you want to have on your tests. So define, for instance, this purchase user scenario will execute a reserve process plus and then a purchase process. So I can say that I'm going to first do a reservation with this process. Once that's done, my user will do a purchase. So I can easily just put new processes here with exec and then adding what I want to do next. And this is just to set things up. So now that we have everything defined, we can set up what I actually want to do. And in here, for each one of these, for me, experiences or scenarios that I have defined, I can say that for the login scenario, I want you to inject 2 users at once. That means that once I will begin to start, when I will begin to test, I will automatically add 2 users of at least 2 scenarios of 2 virtual users that will use these scenarios of login users. Reserve users, I will start 4 at once, and purchase users, I will, instead of injecting them directly since the beginning, I will increase from 0 to 10 for 1 minute. That means that instead of injecting the 10 users at the beginning and they start doing operations, it will inject a small amount or divide those 10 users during a 1 minute until it reaches the 10 users. And it allows me to do one thing that is really important here, that is defining assertions. So this will define if the test is successful or not. And in here, we have a lot of possibilities. And you will see in the documentation, so access it. Even the definition of how many users, the ramp users, you have other possibilities here. This is just an example. Regarding assertions, so once you have the setup that will define what are the scenarios you're going to execute of this simulation, you will need to say to the test what you expect them to validate. In my view, I want globally to look at the response time, and I want it to be less than 5,000 milliseconds regarding the 19th percentile. So this is one of the measures that I care about. So, and also that the failed request should be less or greater than 0. So what this means is I don't want to have any failed requests on my performance test. And the request per second must be less than 500. And of course, I'm going to use the definition of the protocol that I have here. So it's HTTP protocol. That is exactly this one. And this will allow me to execute the tests. So we will see, for me, executing the tests is actually just MVN. Then I'm going to pass the simulation class that I want to execute. You have the possibility to execute different simulations at the same time, but it's a better use case to use one simulation at a time. And just at the end, use Gatling .test to define that we are using Gatling and doing a test. So once I execute this, let me put this terminal a little bit bigger. It will start, well, it will start to execute the tests, and we will see in the output that what is doing. So it's actually already done. The 2 users were already launched. So 100% of the simulation of users is done. Reserve users is already done also. And purchase users, as you can see, is spanning the creation of the virtual users that will exercise that simulation through those that minute. So you have 5 users waiting, and then 5 users done. Then it will iterate and put another one, and this will create the load regarding the operations that we have done here. And you have in the terminal the output that you need to follow through what's happening. Of course, it's subject to being used to, because it's a little bit hard to come by and read that. And at the end, it actually opens up the report. So the report, what happens until now, and what are the metrics that it has recovered from from the test that we are executing. All of the parameters that I just talked to you before that we need to have in order to correlate, it do this automatically. Actually, in here, it will create a folder where you have all of the executions that I've made. So you see that I have prepared myself because I tested this many times. if you need to automate and to try to read this into somewhere, they had a TXT, so a text file, where they have the last execution available. So it's just a matter of read what is in here, and you can go to the directory of the last execution. It's usually the last one. And in here, it will produce HTML page that is exactly the report, all of the colorful report that you have generated automatically by Gatling. Of course, it will put here, let me just show you, everything that's happening regarding the requests that were done during the test, and all of the times that are registered for you to have that information. Coming back to the terminal, it also says that, well, I have generated this report here. So let me just open this up. I add it here. So this is the old one. Let me just add the new one. And in here, we can see that we have those three. We have all of the assertions that I have defined. At this time, they are all okay. So nothing has failed. We can see how many requests that I have. And we can jump into some details. So in here, you can see per simulation what's happening for the reserve, for the login. And it actually detected a redirect, so it also registered it. And you have here all of the response time percentiles, number of requests per second, number of response per second, and response time. So you have here a lot of data that you can parse, to look, to be able to redraw some conclusions. So this is the test. It will allow you to do this. I don't have actually an integration in Jenkins, but I want just to show you, because what happens here at the end, you will have this report, but while it's running, you don't really know what's happening. So let me just spin up. I have here, I'm going to spin up one Graphite, a Docker Graphite and a Docker Grafana that will help me visualize what's happening on my test. So the only thing I did here is define on the configuration, let me put this smaller, that I'm going to use Graphite. So Graphite is a database that will allow me to record or to send to it all of the metrics that I have been gathering with this test. And in here, I'm defining where it is. So it's actually a Docker instance that I'm just launched. And once I did this, once I execute this again, I will be able to see, let me just execute again, and just jumping to Grafana, that is actually the instance running in my machine, that where I have defined in the Gatling board. That is exactly what we are seeing here, that will have in real time, as you can see, what's happening on the performance test that you are doing, because you have the ability now that you have the metrics being sent to Graphite to build boards that will allow you and your team to understand what's happening into your performance tests. So I think this is really cool, and it's a really good way to start being use of what will happen in production and what are the metrics that you may find in production that may translate to issues or not. So if you are used to look at this kind of boards, it will allow you to draw conclusions about it. Let me just show you under the hood what this is.
Cristiano, sorry to disturb you. Yeah, but I think we are over time already. So if we can move to conclusion, because there's some Q&A also, we'll take some questions and answers. Yeah. So I think,
let me just briefly go over the last example I have here, just to showcase one of the possibilities, that is the feeder. Gatling also has a feeder there. That is the possibility to define in a file kind of a data set that you want to use. To be used in your test. So in here, I have to define this CSV where I have keys and I have values. And I just want do the same test, but this time I'm going to extract the data from a feeder in a random form. So it will randomly take values from this feeder, and then I'm going to pass them to these tests. So I need to replace the value with this form, and this is search from key. So it's the value of the key that I've put it at the first line. And how do I say the user to use this feeder is actually when I'm defining my scenario, just say that I'm using the feeder once I want to execute this simulation. And then the rest is exactly the same. I'm not going to show you this executing, but this is just another possibility sometimes that is really useful for us to go. In here, let me just show that once I'm connecting this Grafana to the Graphite, I have all of the indicators or all of the metrics that I have here that I can build my boards over. So this is actually really cool. If you don't know Grafana and Graphite, please go ahead and try it out. You won't go into observability world without it for sure, because they are literally everywhere.